Welcome to Electronic Geek. In this video, we will see about decoders and we will design a 3:8 decoder circuit on Proteus and we will simulate it. In this video, we will be covering different topics related to decoder, like we will start with difference between a demultiplexer and a decoder. Another is active high versus active low decoder, and finally we will be doing the implementation of all these concepts and we will design a 3:8 decoder circuit on Proteus and we'll simulate it. So let's get started. Firstly, we will be starting with the differences between a demultiplexer and a decoder. So if you compare the basic circuit of a demultiplexer with a decoder, these are the basic differences that are present. The first thing is the demultiplexer has control switches which are responsible for selection purposes. That is, for example, if you are having a 1:8 demultiplexer, then there will be three control switches. I said the number of control switches are determined by the formula log of the number of output data pins to the base 2. So as we are having a 1:8 demux, so by that formula you get log 8 to the base 2, which is 3. So you have three control switches, and those three control switches are responsible for assuring as to which particular output shall be high. In case of a decoder, there is no such control pin. There are no control pins. So this is the first point. And other point is, in case of a demultiplexer, you have one single data input and n number of output, whereas in case of a decoder, you have many input lines. Let's say you are having three data lines at the input. Then by the formula of 2 raised to n, that is n actually stands for the number of input data lines, so the output data lines shall be 2 raised to 3, which is 8. In case of a decoder, as there are no select switches, the output line of the decoder is dependent on your input lines. For example, if your inputs are all 0 0 0, then the output line 0 shall be connector or shall be high. So this is the basic difference between a demux and a decoder. So now let's proceed to the design part of a decoder, and before that we'll see the truth table, and I have it in my notes, so let's check out it. See, this is the truth table of a 3:8 decoder circuit. Here, this E is the enable pin, which is always supposed to be kept high. We are not talking about ICs where the enable pin can be active low, so this enable will be 0 in that case, but not here. These three are the input data lines A, B, and C, and these eight lines are the output line. As said before, 2 raised to n gives you the output. As n here is 3, A, B, and C, 3 input lines, so 8 output lines. So yeah, so this is the truth table, and every output, the logical expression for every output is this. You can say y0 is E, which is always held high, then A bar, B bar, C bar. As all are 0, we need all the inputs need to be complemented in order to get y0 as high. So now in case of y1, enable is always high, then it will be A bar, B bar, and C. In this case it will be A bar, B, C bar. In this case it will be A bar, B, C. As now A is high over here and other two bar low, it shall be A, B bar, C bar. Here it is A, B bar, C, A, B, C bar, and as all are high, no need to take complement, it will be A, B, C, and enable as well. Now, as we are done with the truth table part, now we will proceed to the next topic, which is the active high versus the active low decoder. So there is a basic difference between an active high device and an active low. Active high device means whenever you trigger something, like you adjust your input, and as per that change in input, the particular output will be going high. Means if you consider an LED, in case of an active high circuit, if you choose a one particular data line, then the LED connected to that particular data line will be glowing. That means the output shall be high. In case of an active high decoder, in this case, could be some other device in other case. In case of active low, the data line with the output data line which you select with the help of your input line, the particular data line on the output shall be low. That means if you select a particular output data and let's say D3, and if you are using an active low device, then your output shall be low for that particular data line, while the rest shall be pulled high. So this is the basic difference. I will be demonstrating and showing it to you. By the way, in this video we are focusing on 3:8 active high decoder circuit. So we will see what an active high decoder is when we are done with the design. So let's start with the design part. Firstly, we will be needing the components, and as we can see that our each output term has four variables, so we will be needing four input AND gate. So search for it. We shall be using this one. This is the four input AND gate that we will be using. Even a NOT gate will be required to invert the output. Sorry, invert the input. This one. LEDs, red LED, and toggle switches. Yeah, okay. So as we have 8 outputs, there shall be 8 AND gates on the output. So 8 outputs, 1, 2, 3, 4, 5, 6, 7, and 8. LED shall be connected to all these outputs. Even connecting with that. We will have to adjust each of these LEDs. And yeah, all are adjusted. Now our implementation part. The first term was enable A bar, B bar, and C bar. So we will be needing 4 logic toggle switches. Here it is. So these are the 4 logic toggle switches, and we also need the inverted signals. So using the NOT gate we can achieve that as well. Remove this part over here. Yeah, so connect all these, and now the output of each NOT gate will be giving you inverted. And yeah, but one more thing, if you are providing the enable pin, if you are connecting the enable pin through a NOT gate, then make sure you do not pull the enable pin high. So in this case, let's better remove it, so it will be even distinguished a bit. Yeah, so this is the enable pin, and this is A, B, and C. So it's, uh, it's better to use net labels only. En shall be the net label. En stands for enable, and all of these will be connected to enable. Now place the net label for all. En. For the rest, yeah, all the lengthy connections are done, and we are ready to connect it. As all enable pin is connected to all of these AND gates, we will pull it high before and only. Now our first term is A bar, B bar, C bar. So connect it like this. This is C bar actually. This is B bar. This is A bar. This is A bar. Connect the output LED. And the next term is A bar, B bar, C. So again do the same thing of net labels. We could have done it before, but it's fine. Write this as A bar and this as B bar, and this as C bar. So now this particular term was A bar, B bar, C. So sorry, it shall be A bar, B bar, and this was state C. So it's better to take it like this. You can place a net label over here, like call it C, and do that same thing with all the rest. So it's extremely easy. What you are supposed to do is simply write the names on wire and it will get connected. See, your even the second term is now ready. The third one is A bar, B, C bar. So A bar, A bar, B, C bar. Done. For the third output also. Fourth term is A bar, B, C. So A bar, B, C, and connect it. Now the next term is a b bar c bar. A b bar c bar, and connect the LED. Next is A B bar C, A B bar C. The next one is A B C bar, A B C bar, and the last one is ABC. And connect to the LED spindle. What you are left with is grounding of LEDs, so simply connect it to the ground. All the LEDs are grounded and your circuit is ready. So we are about to simulate, and as this is an active high decoder, the switching position selected over here should reflect by on the output line by the glowing of LED. So let's check. When all of these three are 0, our first LED should glow. Let's check it out. Yeah, see, our first LED is glowing. Now let's change the input. This is A, B and C. So let's change this from 000 to 001. See, active high. As I am switching the inputs, as I'm changing the inputs, the output is changing by glowing. If this was active low case right now, all these LEDs would be glowing, and this particular D2 LED would be off. We will be seeing active low in the next video. Now change this to 011. See, now 101, 100, 110, sorry, 110 and 111. All the LEDs have been glowed. This is what an active high decoder is. This was the circuit diagram and the entire simulation for the circuit. Now coming to the application part of this entire circuit, like we made it, but where can this circuit be implemented and it can be used? Now as you have seen, your output depends upon your input. So if at all you are making a circuit where you need to constantly change your outputs based on the inputs, you can use a demultiplexer or a decoder circuit. If many are there, you prefer using decoder. If less are there, if only one is there, then you can use a demux. Other application is in computer memory, where your output of registers or these particular blocks are activated only when it receives a command. So receiving a command is a digital signal, and yeah, it can be controlled and you can get that particular task done on your output. So all the places where you need to control your output using some kind of a switching action, this particular decoder circuit can be implemented and it can be used. So this is it for this video. In the next video we will be seeing an active low decoder, and thank you for being till here. Thank you so much. Please do like, share, and please subscribe to my channel, and do let me know your feedback in the comment section. Thank you for being till here. Thank you so much.